We're going to move right on into to our film.
The night ascent's pretty spectacular. You look out the window and it's like a welding torch going off when the SRBs light. KT got to look out the overhead windows, and I think that was pretty spectacular too.
It looked like daylight behind us on the pad, and I could follow it for maybe 20 seconds before it went into just light, just fire behind us.
The vibrations and the roar is pretty much the same as in the daytime. Probably the big difference is up when you get towards SRB SEP. When the rockets go off to separate those boosters, it really flashes outside the windows, and it gives me a thrill just seeing that right there.
I tried to warn these guys.
Yeah, Covey warned us, but it was still exciting. The engines worked pretty well, and the next thing you know, we were up on orbit, saw a beautiful sunrise.
Because of the altitude of the Hubble Space Telescope, we got to go into a relatively high, inserted into a high orbit. What we found almost immediately is this orbit allowed us greater views than we had seen before on any of our flights. This was what Houston looked like at night. In fact, you can follow a Gulf Freeway down to the bottom part of the picture. You can see Clear Lake and Texas City and Galveston all in there. We never saw the U.S. In the daytime. We saw it at night, but this shows you some of the view of the lights. If you see New Orleans just going off the left side of the screen, at the far top left is Chicago. Center screen is Atlanta. As we come across here, you can see the lights of Florida and then on up the East Coast. Post-insertion is a busy time for the crew. You're adapting to zero-G and the spectacular views, but we were able to get everything cleaned up and ready for our stay in orbit. This shows the crew members at their different positions and being busy. Claude and Jeff and Story and Tom trying to work on our rat's nest of photo TV equipment over in the corner.
There's our beautiful payload bay again, just waiting for us to go to work out there. Here we're getting ready for the rendezvous.
Yeah, before those guys could go to work, we had to get the orbiter up there. And this next sequence will give you a feel just how busy it is during a rendezvous. Covey, Claude, and I were working up front most of the time, maneuvering the orbiter, and then Covey moved back to the aft station. Everybody else was busy taking pictures, like with this IMAX camera, shooting a laser out the window, and getting pictures like that of the telescope. The closer we got, the more excited I got. And, I was pretty impressed when I got my first view out the window, and that's just what it looked like. You can see the blue glow from the Earth below.
And this is the final approach to the telescope. Covey was flying the orbiter in a very professional way and stabilized the orbiter versus the telescope in such a position that I could grab it. The remote manipulator system had been already put in the poised for capture position about an hour before the final grapple. And this is the final grapple. We saw the target that I was using in order to position the end effector on the telescope and grab it and rigidize it, and then move it in the aft cargo bay to install it on the flight service structure.
We had checked out the suits on flight day 2, so we knew we had 4 good suits going into this. We'd spent a lot of hours training in the water tank, and we were all excited and ready to go do it for real.
Here we are doing it for real on EVA day 1. Get up and stuff some breakfast down, and while you're eating breakfast, you start putting electrodes on. Those are biomet electrodes to get the electrocardiogram off. Next thing you do is KT and Tom put you in a suit. Here's Jeff inside the suit. Then myself, you check out the suits, and if they're all checked out, depressurize the airlock, go outside.
It's an exciting moment when you first open the airlock and you look out and there's the entire universe staring you in the face. So here I am coming out, the first EVA, grabbing onto the manipulator arm while Story is coming out now, and I took a whole bunch of tools on the arm, and the arm is now, under Claude's skillful guidance, carrying me over to where I'll get the manipulator foot restraint, which will then remain attached to the arm. We should tell you some of these EVA shots are actually speeded up 2 or even 4 times because things move pretty slowly. This gives you the basic idea of how we work. One person on the arm, one person moving, helping free floating. The first task, the gyros inside the bay here, I'm opening the doors and Story's coming up and we're ready to go.
And Jeff positions me very carefully inside and puts my feet inside the portable foot restraints. And here we're, as we talked about earlier, changing out 4 out of the 8 gyros. Here we're working on the doors. As you recall, during the flight we had a difficult time closing the doors. So with Jeff on the central handle, myself on a come along, we were able to position the doors and then work the striker plates and get them closed.
And that was something we didn't expect.
And here's myself getting us a leg up on the solar array changeout for the next day. I'm just undoing various bolts there, so when Tom and KT come along, they won't have quite as much work to do on EVA day number 2.
And while Story was doing this, I was working on the fuses. It was pretty spectacular working. You can see right underneath the solar array there this is a view from the elbow camera looking down from the top of the solar array. And we replaced a whole bunch of fuses.
The solar arrays were slewed to the XY plane to prepare for retraction after the end of that EVA. You can see the one on the left is the one that we expected to behave well, and it did. This footage is also sped up a little bit. It took several minutes for this slew to occur. I spent most of this time when it was happening down in the middeck and the airlock cleaning up suits and getting ready for the next day, but I did pop my head up every now and then to watch the retraction so we'd know what was going to happen for tomorrow. This is the good solar array, the plus V2 array, which retracted normally. The bi-stems are being pulled up in the cassette and the blankets rolling smoothly on the drum. And this is the way we wanted them both to work. The other one, we could tell by a kink in the bi-stem, it was unlikely that that was going to be pulled up in the cassette, that we would have to leave this thing partially deployed. The retraction is ground commanded. However, we do have a stop command on board, and we did exercise it when this one was retracting. When the blanket began to get a little bit slack, it seemed like the prudent thing to do was to stop the retraction at that point and let us take care of it by hand when we got out there the next day. This is the kinked bi-stem. The bi-stem is 2 pieces of metal that are flat when they're in the cassette, and when they're released from the cassette, roll up into tubes, one around the other. And it appeared that one of those tubes was 8 or 10 inches longer than the other, so it made some loops in the bi-stem. Story and Jeff were our IVs. They put me and Tom in the suits, as we had done for them the day before, and sent us out to do our work. As I said earlier, this jettison had to be done at, the disconnecting of the electrical connections had to be done at night, because with the solar array still deployed, it is still producing electricity when the sun is on it. So Tom had to cut some lock wire and take some connectors off and open the clamp while I was holding it, because the solar array tended to flap and move around a lot anytime anybody was touching it. I held it up there and let it go with no rates on it at all. It was very, very stable. Claude pulled me back away from it, and then Sox did the separation maneuver that pushed us away from it. And you can see some of the jets fire. The solar array begins flapping, and it looked like a giant bird, giant soaring bird over the desert. It was just the most incredible sight. I was mesmerized for a period of time just watching it. There's not much more you can say about it. It's just fabulous. You see the Red Sea and the Gulf of Aden, and it was one spectacular sight. On the solar array that retracted properly, they were unable to stow it by ground command because it wasn't slewed in the right direction. The latches were not going to mate when it came up to the top, so we did that manually as well. Tom was driving it up with a wrench, although it was actually coasting on its own pretty much, and I went up to the top to be sure that I had my hand on it when it got close to the telescope, so we didn't do any damage by slamming it in. We removed that one, put it on the solar array carrier. It's been brought back to Earth for people to study and see what life is like in orbit, for 3 years of orbit for solar arrays, and what we can do to future solar arrays to make them better. This was our first mass handling exercise. It weighs between 300 and 400 pounds, and it moves as if it's nothing. Just put your hand on it, and pretty much just the natural forces in the suit cause your hands to want to be in a semi-closed position, and that's all it takes to hang on to it. I held it in place while Tom closed the clamp, to mechanically connect it to the telescope, and then I came down to help with the electrical connections. The connectors are driven in place by one drive screw, and we were very, very concerned about stripping that screw because it had happened in ground testing at times. So we opted to drive that by hand very, very gently so that we would feel if there were any kind of torques that we weren't expecting, we could back off and try it again.
After each EVA, we had to go through, it was really about a 3-hour process to clean up the old suits, pack them up for the night, get the new suits out before we're ready to go. And here we are on the 3rd EVA. We talked about the use of these searchlights from inside. This is a good example of what it was like working at night, and the people inside would shine the light to augment our helmet lights. And here I am putting the guide studs, these are little 2-ended bolts, into the wide field planetary camera. This is so that this handhold that I'm picking up now, we can then attach it, and we have a little set of nuts which we then put on top of those guide bolts, or guide studs as we call them. So we take the handhold up, we install it onto the whiff pick. You can see Story free floating over at the right. He's going to get into the foot restraint right below him. I'm undoing the bolts here that hold the whiff pick in, and then the two of us working together actually pull the whiff pick 1 out from the telescope. And it slides out on some tracks, and it just came out really beautifully. Claude doing the driving on the arm. Claude did this so beautifully, it was hardly necessary to say what you wanted to do. He almost anticipated where we needed to be. Both Claude and Sox did an incredible job driving the arm. We stowed the whiff pick 1 on the side of the shuttle in a temporary stowage bracket there, and then extracted the whiff pick number 2. And remember, this is about 4 times real speed. We were doing this very slowly. So slowly that you probably wouldn't want to watch the whole thing in real time. But it came out without a hitch, and then the delicate process of inserting it in, again with me on one side and Story on the other side, went very well, just beautifully. This was very finely designed instrument for EVA repair and handling. It's a good example of what you can do when you design something right. The Story was around back in the Apollo days, and he had commented that nobody had ever taken a Hasselblad into space since Apollo, and so he arranged to have this reactivated, and there I am using it, and we got some fabulous pictures with that. Here we are putting on the magnetometer. It's a unit which we basically put on top of the old magnetometers, so we never remove the old ones, and then we screw it into place. And we're 50 feet above the payload bay, and so not only was it quite a view looking towards the Earth, but looking down towards the shuttle was pretty spectacular.
EVA Day 4, as we mentioned, the swap out the new CoStar instrument for the HSP, opening the doors there, getting into the bay, and then it got dark fairly quickly, so we did the HSP removal in the dark, and you can see the searchlight providing extra light for us there. KT then took the HSP down and stowed it on a temporary fixture over on the port side. Then came and pulled out the new CoStar unit from its stowage container, brought it up, and then held it here, and then pointed the corner down toward me as I came around to remove the DOB, or deployable optical bench, protective cover. All those little mirrors in CoStar are right in that corner, and they're retracted down inside there. And then those were deployed several inches up out of the CoStar several days after we had come home. Getting ready to put CoStar in again, we spent quite a bit of time making sure it's perfectly lined up, and again with only about an inch of clearance. KT did a super job of just giving me millimeters of control when I asked for it, guiding it in, and she might want to say something about how it felt.
It was very easy to move, but it was all I could see in front of my face was a box. So Tom was my eyes to put it in that little hole.
This is getting the new coprocessor out, and then we did a swap out on the end of the arm, and I got on the end of the arm, and KT behind me there to manage tools and the coprocessor. Went up using the power tool. As you noticed here, all the bolts that we had to do except those solar array connector bolts, we used a power tool on, and our tools really held up well and served us well during the mission. Coming back in, this is a good shot of coming back in the airlock. Again, this is 4 or 5 times actual speed, I think. You have to be really careful coming into the airlock. It's got a fragile covering on it. Going out at the end of every day, we had to untether the MFR, or manipulator foot restraint, so if we had to get rid of it overnight, it would come loose from the arm. See all the tools hanging off of each of us as we come in. You had to be very careful coming inside. And then again, at the end of each EVA, getting out of suits, reconfiguring tools and suits, changing out batteries for the next day. This shows Covey, Claude, and Sox configuring MLI for the covers that we were going to put on the magnetometers on the last EVA, EVA day number 5. And here's EVA day number 5. I was on the MFR day 5, and the other 2 days that Jeff and I were out, Jeff was on the MFR, so we took turns at that. Here's Jeff is getting the GHRS, the Goddard High Rate Spectrometer repair kit out. Here's myself and Jeff working on the SATI, the solar ray drive electronics, changing that out. There's not much to look at here. It's just very hand-intensive work, doing mostly electrical connectors for about 3 hours. This is one of the more spectacular views up on top here, looking straight down to Earth, 370 miles. We're getting ready to do put the covers, those MLI covers that we had constructed on top of the magnetometers. Here's deployment of the main solar ray boom. It just took a couple ounces to get it started down, but the motors were unable to deploy that. So Jeff and I, just with a couple ounces on a wrench, were able to deploy the what's called the primary drive mechanism, but it's really just a solar ray boom. Here's deployment of the new solar rays, the blankets, which will go out there and convert solar energy into electrical energy. But this is the final completion, really, of the EVA here. They were able to deploy these while we were still out, and also to be able to deploy the high gain antennas and all these things. It was great to get these things done because they did have EVA backups in case any of these mechanisms did not work. Here we are coming inside after the final EVA, EVA day number 5, and we never really did let our hair down until this final day here. We breathed a slight sigh of relief on each day because we got each day's job done. But I'll tell you, we've been working at this for years, incredible attention to detail, and we did have a moment of jubilation here, although, of course, we had many weeks to wait to see that Hubble really did work.
This is flight day 9, the release day. You saw the telescope in the back of the bay ready for release. First, we had to capture the telescope using the arm. You see here the final approach to the grapple fixture on the telescope. Then we released the latches on the flight service structure, lifted Hubble over the flight service structure, over the cargo bay. And here you can see the release of the telescope. The arm is being pulled away, and Sox is at the controls of the orbiter for the separation maneuver.
Yeah, after Claude released the telescope, I fired a few pulses to get us back and away, and the telescope slowly started drifting. Once it was at a safe distance, we put some cameras up in the window, and I hope we got some good photos, especially with the IMAX camera. And that's what it looked like, a pretty majestic sight with that big telescope and its brand new solar arrays drifting away. We got lots of film, and we can't wait to see it. I think we're making an advanced screening here on Thursday or Friday of some of our IMAX footage.
After deploy, we did, as Sox talked about earlier, had a day off. It shows some of the activities on our light day, and actually on every day, reading the mail that we'd get up on our through our computers. Here's Sox doing some trash compaction and management, and KT's taking care of the laundry. And
This is after she cooked.
we also, on the day before entry, practiced landing with our new pilot simulator. It's a little onboard computer simulation of the landing task, and it proved extremely useful to us for getting ready for landing.
We had great passes over North America and Europe, and this is a pass over the Mediterranean Sea, or south of Mediterranean Sea. You can see Sicily and the southern tip of Italy. We just could see Rome that disappeared on the left-hand side, and Brindisi on the right-hand side. A little later, we had passes over the delta of the Nile, and you can see Cairo in the middle. And a little further north, the lights of Tel Aviv and the west coast.
And here's the west coast of the U.S. as we complete our trip around the world. You can see San Francisco Bay up in the center, Los Angeles down at the bottom, Las Vegas coming into view. Las Vegas is outrageously bright. You could see the strip from 350 miles. This is Houston. Take a look in the upper left corner and you'll see a very bright fireball meteor come through the atmosphere. There it is. You can also see Dallas and San Antonio. This is looking up the east coast. You can see lightning storms. You can see a little bit of aurora up there. Looking back towards the west now over Florida, you can see all the way back to Houston.
We had a lot of long hours and intense days, and when Covey said it was time to go to bed, it was time to go to bed. And he covered the windows and sent the kids down to the middeck. With 5 of us sleeping down there, it was pretty cozy. You knew if you moved, you were waking somebody else up. But we managed to all find a place to strap our sleeping bags and set story to the airlock. For that, on our get ready to come home day, this was flight control checkout. We're making sure all the orbiter systems are working. We brought home everything that we had intended to bring home with the exception of that one solar ray. And the solar ray carrier looks like a tool board in your garage with one tool missing, so we call that our dead tool silhouette. This is HST. It continued to stay with us through the rest of the flight, and we called it our morning star because we would see it every morning when the sun was reflecting off of it.
All missions have to end. They end with a deorbit and a landing, hopefully, and this shows us getting ready for a deorbit, and then the infrared pictures from KSC and Cape Canaveral Air Force Station of our turn around to Hack and approach to runway 33 at the Kennedy Space Center. And like I said before, there's nothing like bringing a space shuttle back to the Kennedy Space Center. We had an extraordinary night to fly across Florida with the lights and to make this landing onto runway 33. The orbiter flies exceptionally well for a big glider, and we felt very good about safely rolling out to a stop and bringing STS-61, the servicing and repair mission, to a conclusion.